Okay, so this is the third lesson then on functions. We've done 2 lessons already. The first lesson I introduced you functions with the domain and range. The second lesson then we looked at composite functions. And the last bit now that we need to look at today is called finding an inverse function. So in your booklet we are going from page 43 onwards today. Here's a quick starter for you to try, where you've got 2 functions and I've asked you to evaluate 3 things. So pause the PowerPoint now to have a go at the starter, and on the next slide I'm going to go through the answers. So I'm going to go through the answers now to the starter. If you haven't had a chance to do it yet, please pause the PowerPoint and have a go. So f of 1 is the first question. So that one should be nice and easy. We just substitute the number 1 into function f. So that means we're doing 4 times 1 squared add 3, which is obviously 7. The second one, fg of 2. Well, first of all, it might help for us to write down what fg of x would be. So as a side note, fg of x, remember from composite functions, you do the functions in the reverse order to how they're written. So this one means that g happens first. So if I just write down what g is, so that's what function g was. So I've done function g. Now I've got to do f to that. So I've got to substitute that into function f. So function f says square it, put 4 in front, and then add 3. So now that I've written down what fg of x is, I can now work out what fg of 2 is. So it's going to be 4 brackets 1 over 2, so I'm replacing that x with the 2, squared add 3. So half squared is a quarter, 4 times a quarter is 1, 1 add 3 is 4. Now that's not the only way of working at that one, so you may have done it in a different method. So an alternative way of doing that question would be to work out what g of 2 is first. I'm doing function g first, remember. So g of 2 would be 1 over 2. And then put that into function f. So do f of a half, which would be 4 times a half squared add 3, which hopefully you can see is the same as what I did earlier. Last one then, gf of x. This time we're doing function f first. So if I write down what function f is, it's 4x squared add 3. And then I've got to do g to that, which means that I've got to substitute that into function g. Now g of x says to do 1 over whatever you're substituting in. So I've conveniently left a nice space above so I can just simply write 1 over. So 1 over 4x squared add 3 is my final answer. Okay, so these are the things that we're going to concentrate on today then. Deriving inverse functions, understanding the conditions for an inverse to exist, and then understanding the relationship between the graph of functions and their inverses. So first of all, let's define what an inverse function is. It's exactly what you'd expect. An inverse function performs the opposite operation to a function. So inverse is the opposite. It takes the elements of the range and maps them back into the elements of the domain. So looking at the picture, if we started with some numbers, let's call them x's, x coordinates, and we perform a function, function f of x, that's going to give us some outputs, y. Remember that we call the inputs the domain and then the outputs the outputs the range. The opposite to that then is the inverse function. That's the one that would do all the opposite things and it would get us back from our range back into our domain. So it performs then this sort of cyclic pattern where you could go round and round in circles. The notation that we use looks like this: f minus 1 of x this is not the same as f to the power of minus 1. So please don't confuse this with having a minus 1 power. That's not what it means. This minus 1 is a notation that we use for inverses. You've seen it before because you know that the inverse of sine is sine with a minus 1 on it. And you should also know that that doesn't mean sine to the power of minus 1. That's not what it means. It's just a notation that we use for an inverse. And then the last bit on this slide, f minus 1 of x equals f minus 1f of x, which equals x. So what this is saying is that if we take two functions and we put them together, remember that's called a composite function. We looked at things like f, g, and gf last lesson. If we now use two functions f and f minus 1, because they are inverses, they sort of cancel each other out. So if you took some numbers, let's call them x for general, and you performed function f to those numbers, and then you performed the inverse function, it would get you back to where you started, back to your starting number. Okay, so a function and its inverse, they just cancel each other out because they're opposites. It's like having a starting position. You take one step forward, then you do the opposite, so you take one step back and you're back exactly where you started. One more thing I've just noticed is really important in this slide. For this reason, inverse functions only exist for one-to-one functions. In our first lesson on functions, we talked about the idea of one-to-one or many-to-one, that sort of thing. An inverse only exists for a one-to-one function because you have to be able to go round and round in circles. So you have to be able to go from an input to an output, and then from that output back to the same input, and then from there to that output again, and then from that output back to that same input. You have to be able to go round and round in circles. If you've got a many-to-one function, then starting from an input you might get an output, but then from an output you might not get back to the same input, and then you might not go round and round in that cyclic motion. So inverse functions only exist for one-to-one functions. So now that we've got an idea of what an inverse function is, it's just the opposite of an original function, we now need to be able to actually find what an inverse function would look like. So this is an example that I've taken from your booklet from page 43, where we're given a function, f of x equals 3 over x minus 1, and we're asked to find its inverse. We're given the domain for this function, but we're not going to use that for a moment. But let's very briefly talk about it. This is the domain. It's not really important to this question, but let's have a quick look at it. X has to be a real number, and x is not allowed to be equal to 1. So it's telling us that we can put whatever we want into this function as long as it's not 1. Perhaps you can spot why 1's not allowed to go into this function. Imagine what would happen if you tried putting 1 in there. Can you see that on the bottom you'd have 1 minus 1, which is 0, so you'd be trying to divide by 0, which we know is not possible. But anyway, back to the function, f of x equals 3 over x minus 1. We want to try and find its inverse. Now there's a really nice, quite straightforward way of finding inverses, and that is to change the subject of the formula. So what we do first of all, we write down what the function looks like at the moment, and we put it equal to y. So at the moment, y is the subject of the formula. And what I'm going to do is I'm going to rearrange it to make x the subject of the formula. And in my process of rearranging, I'm going to change things into their opposites. So I'm rearranging the formula to get it from saying y equals to becoming x equals. So first of all then, this denominator, let's take that up to the left hand side. So I'm going to write y bracket x minus 1 equals 3. So I've just multiplied both sides by x minus 1. In the original function, it was divide by x minus 1. I've just multiplied by x minus 1, so you can see where I'm doing inverses. Next, I'm going to take the y over to the right-hand side by dividing by y. So x minus 1 equals 3 over y. You might be comfortable doing that all in one step, and if you are, please do. All I've done really there is I've swapped over the y and the x minus 1. Remember, I'm trying to get x on its own. X is nearly on its own. The only thing with it now is this minus 1, which I can move by adding 1 onto the other side. So in my original function, I could see a minus 1. Now I can see an add 1. So again, hopefully you can see now where these opposites are coming in. So I've rearranged the expression I started with. So I started with this, with y being the subject of the formula, and now I've rearranged it to get this. So now x is the subject of the formula. This now is pretty much the answer to the question. Find the inverse of f of x. Well, the inverse, remember the notation we use is this. And my answer is practically in this box. It's going to be this part, 3 over y plus 1, but we don't write our answer in terms of y, we're writing our answer in terms of x. So if I just, instead of writing a y, if I just write an x instead, then I've got my final answer. This is the inverse. So you can see it was very easy to do. Step 1, write your function equal to y. Step 2, rearrange it to make x the subject of the formula. And after you've rearranged it, that's your inverse function. Just remember that if you're going to write it as the inverse f minus 1 of x, then you need to have an x in your answer. There's no good saying that you're going to do f minus 1 of x and then putting a y in there. We want it written in terms of x. So here's a question for you to have a go at. Got a function there, f of x, which is 1 over 2 minus x. And the domain is that x is any real number that cannot equal 2. And I want you to find the inverse. So pause the PowerPoint. See if you can find that inverse function. So I'm going to go through the answer now to that one. So if you haven't had a chance to try it yet, please stop the PowerPoint now and have a go at it. Step 1, put y equal to 1 over 2 minus x. And then step 2, rearrange it, jig it all around to get x on its own. So you could start off by taking the 2 minus x up to the right hand side, and then the y over to the right, sorry, the 2 minus x to the left, the y to the right. This time, because there's a minus x, personally what I would do is I would take that minus x over. It's not very nice dealing with a minus x. So if I take that over to the right hand side, now it's positive. And then I could just subtract the 1 over y fraction. Now that's definitely not the only way of doing that, but that would be my preference. If you want x on its own, you don't want it to be a negative x, you want it to be an x. So if you take a negative x over to the other side, make it a positive, it just makes life a little bit easier. So my inverse function, I can use what I've got here. Just remember that we don't want it in terms of y, we want it in terms of x. So I'm going to write this as 2 minus 1 over x, and there's my answer.